Hi, this is David Korsendorfer, and I'll be the instructor for the ILR class on the geology of Arizona and the southwestern United States. As Sun City residents, we are all well aware of the geology in our part of the state, as the rocks of the Catalina Mountains stare down on us every day. As we venture from our homes to other parts of the state, we become equally awed by the visible rock exposure in the Tucson and Rincon Mountains, and as we travel north, we are further impressed by the extent of the geologic sequences found in the Grand Canyon and other parts of the southwestern United States. This four-session course is a repeat of what we offered last year, and we'll start by reintroducing some geologic concepts, including the importance of minerals and the basic rock types and how they form, the concepts of stratigraphy and how they are used to decipher our geologic past, geologic time, and lastly, how plate tectonics controls the process of continental growth and evolution. This will basically be a review of your College Geology 101 class that you may have taken many, many years ago. In the second class, we'll examine the evolution of the North American continent from the beginning of time, 4.6 billion years ago, through the end of the Mesozoic period, when the age of dinosaurs ended. The earliest of Earth's time, known as the Precambrian era, witnessed the formation of our oceans and atmosphere, as well as the initial supercontinents and the early mountain building episodes in Arizona. With the beginnings of life in the Paleozoic era, Arizona was on the western edge of the North American continent. At that time, the western continental boundary was relatively quiet, and changing sea levels gave rise to an accumulation of thick sedimentary rock sequences in the southwest U.S., such as we see in the Grand Canyon. As we move into the Mesozoic era, the tectonic activity increased along with magmatic activity and volcanism. A large inland sea gave rise to alluvial drainage systems, dinosaurs, the impressive petrified forests were all products of this time. The Mesozoic era ended with the meteorite impact that wiped out the dinosaurs, along with 75% of all plant and animal species. In the third class, we'll look at the Cenozoic era, the most recent time period from 66 million years ago to the present, and how the modern Southwest landscape was formed. The Sevier and Laramide orogenies, which are mountain building episodes, had huge influences on modern-day landforms in Arizona and the western U.S. This was a time of extensive mountain building. It lasted over 100 million years and gave rise to many of the mountain systems we see today, as well as the abundant mineral deposits found here in Arizona. 20 million years ago, our region saw a change in plate tectonic regimes, and it changed over from an environment where collision dominated the tectonics to one of extension, where the pulling apart of the continent gave rise to a broad uplift and extensional features such as the Basin and Range Province, the Colorado Plateau, as well as the Santa Catalina Mountains. We'll end the third session by looking at the origins and details of Arizona's rich mineral deposits. In the fourth and last class, we'll take a virtual geologic tour of many of the landforms found in Arizona and the southwestern U.S. We'll look at how the erosional processes gave rise to the Grand Canyon, Bryce and Zion Canyons, as well as Arches National Park and the Grand Staircase. We'll also talk about many of the landforms in Arizona, such as Barringer Crater, Petrified National Forest, Slot Canyons, Sedona, Picacho Peak, the Salt River Canyon, and many more. Overall, this is an ambitious class. It covers a lot of material and some complex concepts. Each class will last about 2 hours, and we'll take a 10-minute break midway through class. We will try and send out the outline and slide decks prior to each class, and we'll do our best not to let it get too dry. So hopefully we'll see you in class, and I am looking forward to it very, very much. Thank you.